Happy Monday! Another week of learning math online. Hope you guys are doing well. If you're watching this and you're at home, that's awesome. If you watched this after you came to school and did a tutoring session with me, that's even more awesome. Don't forget, today is the day that I have my tutoring sessions. So all you have to do is sign up so I know how many kids I have. And you can come whenever you need to, as long as there's no more than 9 people per time slot, from 9 to 10, 10 to 11, 11 to 12, and 12 to 1. So make sure you're doing that. A lot of you guys had some things you got wrong from last week, and if you come in, we can work on it together and you can get a better grade. So I would really hope that you're watching this video after you've already come to see me at school. That would be the most beneficial. But if not, I hope this video helps you understand what we're going to learn about today. So this week we're finishing up some stuff with numbers, reviewing things with numbers, how we classify numbers, how we add and subtract and multiply and multi-step equation and move things around, and how we work with fractions. And now we're going to look at exponents. So I know you guys have learned your exponent rules before, but we're going to refresh our memories. I'll put a picture of these completed on Classroom, as I always do, but you guys need to start watching these videos. I'm not getting enough people watching the videos, and you're confused when you haven't used the resources that have been given to you. So let's go through these notes. I stopped when we got to the examples because I want to do these with you so you can see them in real time. And I also want to explain some other stuff. So what is an exponent, in case you forgot? It is a number raised up higher than your base number. So when you're looking at stuff written down, an exponent will be up in a different playing field than just your regular base numbers. And an exponent tells you how many times to multiply that base number by itself. So this would be where your base number would be. The exponent would be up above it. So if we had an example of 2 to the third power, and this is how you would say it, 2 to the third power, it means you're going to multiply 2 by itself 3 times. So this also, let me write this here, means 2 times 2 times 2. So the exponent lets you know how many times to multiply your base number by itself. There's no other numbers happening. It is not 2 times 3. 2 times 3 is written on the same playing field. 2 times 3, the numbers are the same size. Your exponent will always be a little bit smaller and up higher. So when you're multiplying exponents that have the same base number, there's some rules that we can remember so that we don't have to do as much work. All you have to do is add your exponents. Okay, so if there's a coefficient that's out in front of that base, make sure that you multiply it. But otherwise, you're just going to add the exponent. So I have a to the x times a to the v equals a to the x plus v. So you can literally just add those exponents. And there's some really great visual examples online that explain that. So I'll also put another example right here to help you. 2 to the second times 2 to the third equals 2 to the fifth, right? Because we added them. Well, this is basically 2 times 2, and this is basically 2 times 2 times 2. So can you tell me how many 2's you see? 1, 2, 3, 4, 5. So this is the exact same thing as saying 2 5 times. Multiply 2 by itself 5 times. And so this is why you can just add the exponents. Because if you were to actually do all the math and expand it all out, you're doing the same thing. But it's easier to just, if the bases are the same, just add those numbers because that's what you're doing in the long run. So if we look down here, we've got an example. We have, I'll use orange. We have an x value in both, and I'll use a light green, a y value in both, and we're multiplying. So when we multiply these, we can actually just add those exponents to the same bases. So for my x bases, right, I can just add these exponents together because the base is the same. But if there's any number out front, make sure that you multiply those together. So 3 times 2 would give me, I'll write it here, 6. Keep your x there. Okay, so 3 times 2 is the 6. We're working with the x, so let's just combine those exponents. 3 and 2 is 5. And then now we're just going to look at the y's. There's no number out front to multiply, so let's just bring over the y. There's no number. And add the exponents. 4 and 1 is 5. So we have 6x to the 5th, y to the 5th as our answer. So now I just want to do some more examples down this page so that we have more to work with. And then we'll do another page on dividing. So you'll have the multiplication page and the dividing page notes. And then we'll start doing some more practice with that as well. Okay. Let's see. Let me give you this example. 7x to the third times x to the 5th, y to the 2nd. Okay, when we look at this example, we are multiplying exponents that have the same base. So right here I see a base of x and a base of x, which means I can combine those exponents. So when I do, if there's a coefficient, you multiply it, right? So there's a 7 here, but there's nothing here. This does not mean that it's 0. 7 times 0 is 0. But if there's nothing out front, always remember, there is an imaginary 1 in front of every single one of these letters. Okay? So this is like saying 1x to the 5th and 1y to the 2nd. Okay, so you can put a 1 out in front of anything. 1 times anything won't change the value of it. A lot of times people don't write this 1 because it doesn't change anything. It's kind of like writing something extra when you don't have to. And we love to not have to write stuff down if we don't have to. Same thing here. There was an imaginary 1 right here. 1y to the 1st times 1y to the 4th. Well, 1 times 1 is still just 1. There's no need to write it. We can clearly see that there's 1y here. So a lot of times you're not going to see a 1 ever really represented. And even if you have no exponent, you could put an exponent of 1 there because, again, it's not going to change the value. And I'll show you an example of that in a second. So if we just look at our x's, what's 7 times 1? I'll do it in orange. It's 7. 7x to the, we're going to combine the 3 and the 5. 3 plus 5 is 8. 7x to the 8, and then is there anything to multiply your y with? No. But we can't just leave it behind. It has to be represented. So all you do, wrong green, darn it. All you do is just bring it over, y to the 2nd. If there's things to combine it with, that's great. If there's not, you just rewrite it. So I'm going to give you an example of one where you can't combine them because nothing is similar, and what you would do. X to the 3rd times y to the 2nd times z. Okay, so if you had an example like this, x to the 3rd times y to the 2nd times z. Well, I don't see any like bases. There's no other x that I can combine this x with and add exponents. There's no other y that I can combine this y with to add my exponents together. And there's no other z. So if there's nothing to combine it with, it's the same when we're doing our multi-step equations. If you can't combine, you just rewrite it side by side. It's just x to the 3rd, y to the 2nd, z. That's all it is. All you can do is put them side by side. You can't combine them. You can't leave them behind. You can't forget about them. You have to represent them. Now, like I was saying a second ago up here, this z does have an exponent on it. We just don't see it because in math, we typically don't write a 1 as coefficients or as exponents or even as a denominator because it's pointless, right? So I could put to the power of 1. It's not going to change anything. That means multiply z 1 time. Well, that would just be z. So this doesn't change anything. So sometimes we don't write those things. It's the same thing as up here. 1y, okay, well, we see that when we see 1y. So we don't have to write that 1. Also, you can make any whole number a fraction by putting it over 1. Every whole number that you visually see has an invisible 1 underneath it. Because if you divide anything by 1, it doesn't change it. So a lot of times in math, there are 1s everywhere. We just don't write them. So know that any variable that doesn't have an exponent does have an imaginary 1 up there. It won't change anything, but it's there. Well, also this is supposed to be 3, not 2. Excuse me. All right, let's do a few more. Let's see, 4. A few more for today, and that'll be it. And like I said, you'll have some practice on this, and then we're going to look at dividing exponents as well. So that will be fun. Okay, let's do 4x squared times 3x squared equals. Okay, so in this example, I only have one variable and it's the same in both. Okay, so I'm going to multiply these coefficients. If you have coefficients out front, you multiply them, right? So 4 times 3 is 12. Bring my x over that I'm talking about, and I'm just going to combine these exponents, by adding them. What's 2 plus 2? 4. 12x to the 4th. Okay. Here's another trick one. N times 2n to the 3rd. Okay, so we're only talking about n. This is the same base, so I can combine them. Some people would write this as 3n to the 3rd, because you would just add this n to these 2n's. But this is not addition. This is multiplication. So what's the imaginary coefficient out front here that we talked about? 1. 1n times 2n. What is 1 times 2? 2. So we have 2n, and now we need to add our exponents. What is 3 plus your imaginary 1? 4. Do not write 3 as the exponent, okay? There is an imaginary 1 over every single variable that we have here. So if you look back at number 1, this y had a 1 written there, but you probably would see that in math as just 3x squared y. And that's it. And you've got to know that this y has an exponent of 1 to be added to that 4, which would give me 5. So down here, if you need to write out your invisible numbers that you aren't able to see to help you, please do. Because 1 times 2 is 2, and 3 plus 1 is 4. So that's another kind that could trick you up. Okay, and the last one, kind of similar to what we just did. One more example. X times x squared. Again, I have some people who would put the answer as 2x squared because they're like, oh, well, that's 2 x's. You cannot add these. Remember, when you do x and x, that's addition. X plus another x, which is 2x, that would be addition. So we don't want to do that. We want to be multiplying. So there's an imaginary 1 out front here and an imaginary 1 out front here. And anything to the power of 1, you're not going to see it, but it is there. So go ahead and write that there if you want to. Okay, so what is 1 times 1? 1. We don't have to write that, right? So it's just 1x. You don't have to write the 1. We're just going to write the x. And what is 2 plus 1? 3. So this is actually x to the third. And also, remember, what this actually means is x times x twice. 1, 2. Right, remember the exponent tells you how many times you multiply that base number by itself. So here you would be multiplying it 2 times. Here it would just be 1 time. So this is x times x times x, which is represented by saying x 3 times by itself. So those are the examples for multiplying. I'm now going to give you your notes on dividing. It's going to be a different page. Today's video might be a little bit longer because I'm going over 2 pages of notes, but you don't have any work to do today. I'm going to give you your work to do tomorrow. So if you can copy these notes down, go over what they're, what these examples mean, how it's explained, watch this video all the way through, then tomorrow you'll have your example pages to do and you won't have to do any notes. And you can just refer back to the notes you already took, and then you can work on tomorrow's examples. Okay, so for dividing exponents, it seems a little more crazy and difficult, but again, we've got rules that we can remember to help us and tricks. So the same as before, if you have any coefficients, we were multiplying them together. Here, if you have any coefficients in your division example, you'll divide them. Then you're going to match up your base letters. And when we're working with our exponents, if it's division, we're just going to subtract them. So if our base numbers were the same in multiplication, we added them. If our base numbers are the same in division, we subtract them. So multiplication goes to addition, division goes to subtraction. And then if your answer turns out negative, just flip the side that it's the side of the fraction that it's on. So the first example that I wrote here, and if you need to pause the video and write this down, as always, feel free to. But we have 12 times a to the 7th times b to the 5th divided by 16 times a to the 2nd, b to the 2nd. And I know that this is all being multiplied together because it's all side by side. Anything that is beside something is representing multiplication. So what I want you to do is look at just the coefficients and then each base letter on its own. So we have 12 over 16. Then we have the a values, a to the 7th divided by a to the 2nd. And then we have the b values, b to the 5th divided by b to the 2nd. So let's just start reducing. 12 divided by 16 reduces down to 3/4. And then because these have the same base, we're just going to subtract the exponents. So it's the base of a to the power of 7 minus 2, and then the base of b to the power of 5 minus 2. So when we simplify this, we have 3 over 4, a to the 5th, b to the 3rd, because 7 minus 2 is 5, 5 minus 2 is 3. Okay, and it's that simple. So you're just literally going down the equation here. 7 minus 2 gives me 5, 5 minus 2 gives me 3. And that's what you're left with, and it always goes up on top. Again, if it's negative, you'll flip it. And I'll show you an example right here, our first example. So our first example is 4n squared divided by 3n to the 4th. Okay, so we have our coefficients, 4 divided by 3. That doesn't simplify. So that's just 4/3. But then it's being multiplied by n to the 2nd divided by n to the 4th. Okay, well, when you do 2 minus 4, you actually end up with 4 over 3 to the -2 power, right? So if we keep those ends there, 2 minus 4 gives us -2. That's on the bottom, right? So we have the 4/3. We have our n values, and 2 minus 4 is actually -2. We don't want negative exponents. Yuck, 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 yuck. So what we're going to do is, I didn't mean to write this in here. I'm so sorry. Completely canceled out whenever we got rid of all of them. What we're going to do is move this n to the -2 up top so that it's no longer negative. So our actual answer would be 4n squared over 3. So you can move this n to the -2 up top, and that essentially is like flipping a fraction. When you flip a fraction, it changes the sign. So that's what you're going to do. Like I said right here, if it's negative, flip the sides. If it's on the bottom, put it on the top. And it's that simple if you have a negative exponent. So let's do a few more examples. Mm-hmm. 2m to the 4th divided by m. Okay, so if we split this and we look at just our numbers, what's the imaginary number in front of this m that we don't need to write, but we know it's there? A 1, right? So we have 2 divided by 1 multiplied by m to the 4th over m to the, again, there's an imaginary exponent of 1 right there. And we know 2 divided by 1 is just 2. What is 4 minus 1? If we're going down and we're subtracting, 4 minus 1, let me zoom in for you, is 3. So it actually ends up just being 2m to the 3rd. Again, because this top number is larger than this bottom number, our exponent is a normal, happy number, and we can keep it up top. On this example above, our top number was smaller than our bottom number, making our actual answer down here a negative that we had to flip back up. Okay, let's do another one. R divided by 2r to the 4th. Okay, so if we split this up, we've got numbers that go first and then letters. Well, let's look at this r. There's some missing stuff, just like we had in this m up here, that we can write to help us not be so confused. Let's write the imaginary 1 that's in front of that, 1 times r, to the power of 1. Again, no one ever writes those things, but they're there. So we have 1 divided by 2, and that's being multiplied by r to the 1st power divided by r to the 4th power. So we split up our numbers and our letters. So when I subtract 1 minus 4, I actually get -3 on the bottom, right? So I have 1 over 2 times r to the -3. Okay, so I put my numbers with my simplified letters, and I got a -3 on the bottom. We don't like negative exponents, so we're gonna flip it, sending that variable with the exponent up top so that it's no longer negative. Remember, you only flip and move that variable that's got a negative exponent up when it's negative. Only do that when it's negative. We're not moving things around when it's not. And let's do one more example. Okay, I have 3x to the 4th divided by x to the 3rd. Now, if you're really getting a hang of this really well, you don't need to split this one out. I know 3 divided by my imaginary 1 is just 3. 4 minus 3 is just 1, so it would just be 3x. But if you want to split it out, we do have an imaginary 1 right here. So we have our numbers, 3 divided by 1, and our letters, x to the 4th divided by x to the 3rd. And we're subtracting top minus bottom. So 3 divided by 1 is just 3. 4 minus 3 is just 1, which would just be x to the 1st. So this is what we get. We have our number here. 4 minus 3 is actually just 1. But what do we know about 1s? We don't have to put to the power of 1. It's redundant. Obviously, if there's no exponent there, it's just x. If there's 1 there, it says multiply x 1 time. And we don't have to represent whole numbers as divided by 1. It doesn't change the value of the whole number. So the most simple way that I can write 3 times x to the first power divided by 1 would be 3x. Right? I know this is 1x. I don't need to put that exponent there. And you can divide any whole number by 1, but we don't have to write that. So that's your notes for today. Like I said, I know this video was a bit longer than normal, but now you have notes on multiplying and dividing exponents, and tomorrow you'll have 2 worksheets to complete on Google Slides for that. So good luck with your notes today. Write them down. You can just mark that you turned in the assignment, even if you're not fully done with your notes, and it lets me know that you were on the classroom at some point today for attendance. Or you can just upload the picture of your notes as well. That works for your attendance too. All right, thanks guys. I'll talk to you later.